thank you very much. Very interesting to come after BOT home care. I do care about cows and their welfare, and I also love the products I produce. A good cheese that's matured enough with so much taste, gastronomy you could find. It's my point of view that we have a huge cultural heritage with our cows as well, and also producing the cultural and biological sustainable landscape in the long term also. That's my concern in mind. But today I'm going to talk more about the, it doesn't work, okay. Yeah. Give a little bit on sensors, introduction, precision livestock farming, a little bit on precision farming, a little bit on the insights and predictions. Mainly predictions will come in the, sorry, my voice is a little bit, didn't work really, yeah. Okay, what's happening around sensors here? Yeah, there's definitely a number of reasons here. It's small profit in animal production. Farmers you hear the story, they're struggling. It's scaling up. We're getting fewer and fewer farmers on bigger farms. There's little time for the individual. There's a need to better control the productivity, health, and the welfare of individual animal. And there's all these stuff we need to control is needed. Develop reproduction, well-being of each animal is very crucial for profitability. We don't want to have a sick animal in the production. We want healthy animals because they are the profitable ones. And today's technology is very promising. We could do a lot of things. It's just to find the right models for it, and we could use it to create added value in our companies, in the farming companies. And without the human being present, the farm is not there on a number of hours per day, but with technology we monitor animals anyway. There are some challenges. There's over 60 million animals slaughtered every year and expected to increase because we have huge demand, especially in the second and third world, East Asia and so on. And there's definitely a protein deficiency in Africa, south of Sahara. And there are definitely a relationship between animal health and healthy food. And animal welfare is a great concern, especially in Europe. There are environmental issues we have to work much more with. It has been worked for a long time, but there's still things to work with. It's a social importance and cultural importance as that. There's an economic importance also for the farming community. And of course we need a better surveillance of our animals, because today normal farmer wouldn't control his he would observe his animals, but then things would happen that they couldn't actually capture the animals, and that would lead to illness, or even the animals were died and so on. So that's a problem we are addressing with using of sensor technology, and also the fertility, nutritional needs, behavior, welfare, and also the function of the equipment here. So the old days, the farmer had the time to look on his and her animals, and the farmer was the audiovisual scorer, and sorry, that's the word. But now we have technologies to actually capture the signals from the animals throughout the day and night and all the time, and we just have to analyze these things. And we could actually use things to capture the lame animal, or we could capture a broiler herd, how it works and how the animals are doing it, how the pigs are doing, and so on. So that will have a huge impact on the sustainability of the sector here. Of course, these sensors measure a number of things of the animals: milk quality, the weight gain, the gaits, the feed consumption, and we have some models to develop for that. and we get some information, and we could get alarm that we could use to treat and to stop the processes happening. And there are a number of sensors to be used. You could use image analyzer, come back to that because of the research we've done. There are different types of sensor. There would be accelerometers are quite common, very cheap. You could use sound, you could use a local lab in the milk robot, for example. Let's see here. And of course, you have to work with this. You have to know what is the gold standard, because you got signals and you have to mark these with a golden standard, so you know what you're doing, and then you do the labeling of that. And of course, and then you build, the work process here is to build different types of algorithms, and then you produce transfer function models, and you could actually make your data useful, and so on. So it is a collaboration type of a process where you need different disciplines and stakeholders involved, and this should be done in a very systematic way. The principles are very generic. You could just use that as an and there's a common understanding, agreement of definitions, and this interdisciplinary collaboration should be that's very efficient. If you and of course you have to validate all these things, like in the sensitivity should be specificity, be the number of true values you get from the sensors divided by what's the true positives and the number of false negatives, and the specificity, the true negatives with the number of true negatives and number of false negatives. So, and all these products that come on the market has to be properly tested and validated. And of course, there's a long list of what we want what we need, and this list is also an area of research. But finding animals in heat, have control of reproduction is really, really essential. And finding lame animals, mastitis, and sick animals, and understanding the feed intake and body condition, whatever. And there are some other things too as well. And of course, you can measure all these things on the cow today. It's absolutely fantastic. It's not only the milk we measure, but we could measure so many things, the body condition automatically, position, location, posture, are important in different ways here. Temperature, sleep is a little bit tricky because you have, but it's done on research. Methane emissions could be measured, respiration, chewing, rumination, lying, standing, activity, mobility, milk yield content, and so on, hoof, health and lameness. So there's so much behavioral interactions we come to as well. Let's slow this one, okay. And there are devices on the market, just a bunch of them, but I'm involved in the European project with 4D4F, and they just mapped the projects available on the market. You could see there are 31 companies working on heat detection, 9 on rumination, 5 on ruminacidosis, 32 on precision feeding, 19 on automatic calf feeders, 30 mastitis, 4 position, 7 on calving prediction, milk analysis, sensors for goats, and temperature. So have a look at this webpage. If you're interested, you register on the page and you get all the things. And I give you some examples here, which are kind of interesting. Reproduction, as I said, is so crucial. It's a driver of a production, and you could use a number of these activity measurements, change in rumination, changes in milk. A cow in heat will actually be having activities, jumping and so on. And of course, you want to. There are devices for finding her when she's about to calf, and this is a little bit tricky one because you put it into the cow and it pops out when she's about to deliver a calf, but there are other indirect measures that could be used also. And of course, let's see, that doesn't work. Okay, let's see. Come back here. I thought it was another one. There's a Swedish company started up some years ago using infrared cameras, based in Linköping, and they use these infrared cameras and they detect the infrared surface of a cow, and they would actually be able to detect mastitis at a very high rate. But there are other measures you could do: teat milk yield for each quarter of a teat, of the udder, conductivity, chemically, somatic cell count measurement, color change. We have the surface temperature here, the rumination, and some behavioral change.
What is mastitis?
Mastitis, it's infection in the udder.
Okay.
Yep. Women can get that too. Yep. But you could use some indirect. Rumination is so crucial for ruminants. Oh, sorry. It's a little bit slow. Lying down and so on. So rumination, a sick animal will start ruminate less, and then it may be something that's happening with her. Here you have the marking the clinical mastitis is here. And of course lying behavior was also connected, so you would see lying time was lower for those sick cows than for the healthy cows, for example. Let's see what's happening here. Come on, yeah. And of course there are very smart devices, just an ear tag with some smart things in it, accelerometer, temperature meter, and you would get some values on each cow every day. You could see the pattern of a cow here. It follows very rumination, eating, not active, active, and high activity. It's fairly normal varying, and then suddenly things started to happening, start being not active a bit too much, and she has a clinical mastitis here, for example. So these sensors actually are used and on farms in Sweden today. The research we do here, we done just recently, had a PhD student finished in 1st of June, and then we looked on the social behavior of animals, which is very new. It's very tedious to look on the if you look manually, it takes a lot of time and so on. But here we were able, together with the Lund University, the Math Center, to use video analysis and automate social interactions among cows. And I hope, and when we have to simplify the cow into a small figure model here, and when we let's see if this movie works. I'm not sure, but let's hope. I don't know if it works, but yeah, you see here, it is working. No, just have it moving. Yeah, it moves. So what we could see here, that there are interactions between the cow and an automated classifying of that interaction. So we are the first in the world to develop this, and so it's been quite a lot of attention to put on this research. Right, so I could just go on here. And of course that's a completely new approach to use the social interactions, and we believe that cows that are not feeling very well, they will have a completely different set of social interactions, or very few than the healthy animal, for example. Okay, there are some challenges for PLF, precision livestock farming. It has to be reliable, it has to work all the time, but it doesn't need to be accurate all the time, but sufficiently accurate. There is too much data on the farms already. We need information, we need insights, and we need some predictions. That's an area we have to work on, and there's a need to develop strategies for prevention and supportive treatments of disease here. I mean, normally farmers would identify a clinical disease, and the veterinarian would come out and also do that identification and do the treatment. So that's moving on to the agricultural side. We think that precision agriculture, have a few examples for crop production here from a colleague here, Mats Söderström, and the Precision Skolan, precisionskolan.se. You can look at that website because it's very useful, very, very good, and gives you quite a lot on what you could use on sensors for crops here. Field monitoring nitrogen application has been one of the biggest things they do. You could use it by using satellite pics, and there's a website on CropSat where you could register, and you could see how much nitrogen your lawn needs at home in your villa. You could have sensors on the tractor, you could have cameras on drones, or you also record a history of your fields, you put in soil characteristics, and then you could optimize the nitrogen in, for example, 20 by 20 acre plots. So we get very much more precise that will have. It will be more economic, there will be less nitrogen leaching, and we also achieve potential yields. And this would be, let's see here. Okay, come on. This would be a satellite picture. You see small squares here, with each with a classification of the nitrogen of that field, and then you put in a steering sensor, and you get the right amount of nitrogen with fertilizer. And of course, the crop sat, well, you could use wireless or USB, and that controls the output from the fertilizer. So it's right, and here you could have these are more indirect. Maybe the data is a couple of days old, but what you use. But if you have a nitrogen sensor on the tractor, that data will collect from the field, and it will immediately control the output from the fertilizer. And a project we have here also at my department is IoT and IoT proof competence in Swedish fruit and wine production. And they have a goal to have a self-learning system, a solution that in a sustainable economic way provides increasing harvest in apple and viticulture. And there will also be a further development for other crops in the green sector and business models to be developed, innovation and sold commercially. And I mean, basically it works having sensors in the field, in the yards, in the what do you call it, orchards. And then you have some connection with protocols and processing of data through the internet, and you process that data and it goes up to the farmer in this one. Yep.
Mr. Coleman, I'd be happy to elaborate on that in the break if anyone wants to, because I'm a member of the project.
Okay, excellent, thank you. And you have a tablet, and so it's. I mean, I just got the slide from my colleague here, so just to mention it. So there are things going on really that will change our things. And also coming to a little bit towards the end here, there's a paradox in the data analysis. The human capacity reduced by the volume of data. We don't understand when it becomes too much. But if you have machine capability increases with you, and of course there's a cognitive ability when you have little amount of data, and the data crunching when we have a lot of data. And of course we will have a productivity point here at some point, but the use of machine learning, we will actually be able to move our analytic ability to a new productivity point, which is much more. This is a company in Spain, Conectera, that works on this one. And they say we don't need more data, we need more insights actually. So it's and they also develop the way of having what you should say on let's say on predictions. We want to have better predictions, and I think predictions are there already. As in some, we could see that in some. These fertility things, you need to have the right insemination time in order to capture when it's more optimal for when the egg becomes loose and you want to have it fertilized in the uterus, then there will be an optimum time for that, and that time frame is now could be predicted by technology here. So conclusions: there's a huge potential of sensors and big data. And it should be regarded as tools of decision support, and they have to be reliable, easy to use. This way, easy to use, we have the companies like Ericsson and Sony that are really good in these things because they work with mobiles, and they know how the interface between man and technology works. And they should make some sense, give insights, predictions, as I said, and then there is absolutely more need to develop predictions of a farm. And there are some legal issues that have to be solved, with data ownership has to be solved, and also develop business model for connected farmers. So the connected cow, there's so much with her, and so yeah, there's so much we could use from the cow and use the sensors that come up to the data here. So, what is big data? Yeah, we decided to take the next level, humongous data. One more time. And of course, data is the ingredients, information. We put big on the cake, we present the cake,